Hi, I'm Bianca Coker from Region 10. I'm one of the math consultants here. In this video, I'd like to talk to you a little bit about one of our new 7th grade standards, 710B. This standard is in the Expressions, Equations, and Relationships strand. The standard states that the student applies mathematical process standards to use one-variable equations and inequalities to represent situations. The student is expected to represent solutions for one-variable two-step equations and inequalities on number lines. Well, in order to represent a solution, I think we need to know what that solution is. Or whether or not it's a correct solution. So to solve inequalities and equations, we're going to need to watch another video, 711A. And in that video, I'm going to show you how to find these solutions, both with concrete models and symbolically. But to find out if the answer is correct, before we graph it, we're going to jump ahead to 711B. Don't blame me for the organization of the standards. So, 711B, this is a twofer video. You get two standards in this video. 711B states that the student applies mathematical process standards to solve one-variable equations and inequalities. The student is expected to determine if the given value or values make or makes the one-variable two-step equations and inequalities true. Okay, so we learned how to solve them in 711A. We solve them and determine if it's true in 711B, and then we graph it in 710B. Don't know, but we're going to go forward with this. Okay, so here's an example. We started the week 2 inches below average on rainfall. And after 4 consecutive days of approximately the same amount of rainfall each day, we ended up with 1 inch above average. How much did it rain each day? So here's our verbal representation that we need to translate into an equation. So the way we do that is we look at our starting amount 2 inches below. So that would be represented by -2. And then we have 4 consecutive days of about the same rain, so 4 times some unknown amount of rain. And we end up with 1 inch above, which is +1. So we have the equation -2 plus 4r equals 1. All right. Now, let's look at that example and see how we solve that equation symbolically. Remember, to solve it with concrete models and connect it to symbolic, you want to watch 711A. But here we go. So, assuming we know how to solve these symbolically, I would add the opposite of -2 to both sides of the equation. And that would simplify to 0, because I have my 0 pair. -2 plus 2 is 0. Plus 4r, and I'll have 3 on the right side of my equation. Now, I'm pretty close to having what r is equal to, but I have 4r. So I'll divide both sides of the equation by 4. And when I do that, I end up with r is equal to 3/4. All right, that's our solution. Now, let's check to see if this is the correct solution. Well, how do we do that? If we take -2 plus 4r equals 1, our original equation, and we substitute our proposed solution, 3/4, in place of r, then we check to see if it's correct. And I like this kind of format here where we start with the equation -2 plus 4r equals 1. And then in the next step, we replace r with our proposed solution, 3/4. And I put a question mark either at the end or over the equal sign, because really that's the question. Is -2 plus 4 with 3/4 replacing r still equal to 1, or is it equal to 1 at all? So I put a question mark there, and then I start simplifying that expression. So -2 is simple, but 4 times 3/4 is 3. And then I'm still not sure that's true, but then when I combine -2 and 3 together, -2 plus 3 is 1. Well, yes, I do know 1 is equal to 1. So that shows that it's true. So I've demonstrated that 3/4 is the solution for this equation using this process. That's one way of doing it. Remember, you can have your students try to do it with manipulatives, but when we get into those rational numbers like 3/4, let's hope they're already in the symbolic, because it's a lot easier to demonstrate that solution. Now, let's look at representing that solution on a number line, the original intent of 710B. So, let's going back to our situation, we started the week 2 inches below average on rainfall, and after 4 consecutive days of approximately the same rainfall, we ended up 1 inch above average. How much did it rain each day? We represented that with an equation. Now let's see what that solution is. Remember, it was 3/4 and we checked it and it was true. So graphing 3/4 on the number line looks something like this. That's exciting. Oh, not really. This is something that's kind of trivial, which is why we almost never graph solutions to equations on a number line. Now it's kind of nice to review the number line model, but really what it does is it sets us up for representing inequalities on a number line, all right? Because those solutions are much more interesting to graph. So let's go ahead and look at that. So if we have an inequality like 4x plus 5 is less than 8, and we find our answer for that, and we find that the answer is 3/4. If I replace 3/4, replace x with 3/4, then I have 3 plus 5, which equals 8. So the answer, or the value that goes in place of x, is 3/4. So what I'm going to do to graph this on the number line is I'm going to check some points. Now the first point we have is 3/4. That's our critical point, and it's the critical point because it's where the left side and the right side are equal to each other. The quantity on the left side and the right side are equal. That's considered a critical point, and it divides our number line into 2 pieces. Those numbers greater than 3/4 and those numbers less than 3/4. Okay? And we have to check each piece of that number line to see if it's correct, to see if it's part of our solution set. So we'll take a sample from each piece of our number line and see if it's true in our inequality. So the first thing we want to check actually is that critical point 3/4. So when we check 3/4 and we put that into our original inequality, we'll have 4 times the quantity 3/4 plus 5 is less than 8. Now when we multiply that out, we'll have 3 plus 5, which is 8. And we're asking ourselves, is 8 less than 8? 8 is not less than 8. It's less than or equal to 8, but that isn't what our inequality is. So because it is not less than 8, 8 is not less than itself, this is a false statement. If it's a false statement, that piece of the number line is not shaded. So we stick with our open circle. Now we're going to look at the numbers that are less than 3/4. And my favorite test point is 0. It's just so easy to put into almost anything. So 0 is less than 3/4, so I'm going to put 0 in place of x in our inequality. 4 times 0 plus 5, and the question is that less than 8? 4 times 0 is 0, plus 5, so the left side simplifies to 5. 5 is less than 8, that's true. If that's true, we're going to shade that part of the number line. Let's check numbers greater than 3/4 next. So in place of x, I'm going to put in 1. Another good test point because it's just kind of so easy. So 4 times 1 plus 5 is what I'm going to have on the left side of my inequality. 4 times 1 plus 5, well that's 4 plus 5 or 9. And then you ask, is 9 less than 8? 9 is not less than 8. That's false. So I'm not going to shade that part of the number line. So on our number line, we have our critical point circled, 3/4. It is not shaded because when we put 3/4 into the inequality, it does not solve our inequality. We checked 0, which is less than 3/4, right? So if 0 is less than 3/4 and it's true, then all numbers less than 3/4 are true, and we're going to shade that part of the number line. And we checked on the other side of 3/4. We checked in 1. 4 times 1 plus 5 is not less than 8. It's false. We don't shade that number line. So we end up with a graphical representation of our solution that looks like this. Now, this might seem like a lot of work. You might want to use a little trick or a little saying so your students know, blah, blah, blah. And yes, sometimes those work all the time. But the reason why we want to get our students used to doing these critical points and testing them out, the purpose behind the standards is because when we're graphing linear inequalities in 2 variables on a coordinate plane, we've got to understand those critical points and test points. They've got to understand what that solution is all about. If it's shaded, that means that those values replacing x or whatever our variable is in the inequality is going to be true. And when it's not shaded, it's going to be false. That is a basic understanding that sometimes when we tell them the quick and easy tricks that we use to find the way to shade our number line, they miss out on the conceptual understanding. So be careful. Don't take the shortcuts. Use test points. Have students testing out those values, just like 711B is asking us to do, to represent solutions for equations and inequalities on a number line as indicated by 710B. All right. I know that's a lot. Rewind if you need to. Have a great day.